Okay, the last video we accomplished learning objective number 1. We sketched some graphs. Now we're going to take a graph and write the function. So we're given a graph here and we have nicely labeled points on it. And we're told that we want to write a transformed sine function. So that means we know that sine starts at the midline and ends at the midline. So I'm going to find a point to begin one period, and I can see that my midline here is at -3. So I'm just going to write that down. Midline, which is D, is -3. I'm also going to tell you how you can calculate it because I like to have a mathematical formula for things. But we can just eyeball it and know that the midline is there at -3. Now, we also know that our A is going to be a negative thing because from 1, -3, we're decreasing. If I had chosen my starting point as 3, -3, then I would have a positive A because I would be increasing. So you always have choices here. But I'm going to follow the PowerPoint, and we're going to start at 1, -3. So A has to be negative. Let's figure out what A has to be. So to find your A is equal to your max minus your min divided by 2. And when I say max, I mean the y-coordinate of your max. So the y-coordinate of my max is -1. The x-coordinate of my max, the y-coordinate of my min, so the y-coordinate of my min is -5. So -1 plus 5 gives me 4 over 2, which is 2. And yeah, you can see we move 2 units down to get to the midline. We move 2 units down to get to the min. We move 2 units up to get back to the midline. So it makes sense that my A is equal to 2. Now, if I didn't figure out D by eyeballing it, it's equal to the max plus the min over 2, which is -1 plus -5 over 2, which is -6 over 2, which is -3. So now I've just confirmed it for myself. So far I know that y is equal to negative A times sine of bx plus c, because I don't know my b's and my c's yet, -3. Now that we've figured out our A and our D, let's figure out our B by looking at the period. So to figure out the period, we want the length of a cycle. So you can find 2 maxes, 2 mins, or 2 midlines. Here I have 2 maxes. There's a max at 0, -1, and at 4, -1. So the length of the period is the difference in those x-coordinates. So find 2 maxes, or 2 mins. Look at the x-coordinates. And the x-coordinates. So 4 minus 0 equals 4. Now, we know that period was equal to 2 pi over b. That implies that b is equal to 2 pi divided by the period which is 2 pi over 4, or pi over 2. Now, our phase shift, we know that we move minus c over b actually just c over b because it's minus c over b, and the c over b is equal to the shift to the right. And our shift to the right is 1, so c over b has to be equal to 1. C over pi halves is equal to 1. C is pi halves. We have it all now. So I'm just going to summarize. A, negative 2. Negative because we start decreasing. B, pi halves. C, pi halves. D was our midline, negative 3. So y is equal to negative 2 times the sine of pi halves times x minus pi halves. And there's no parentheses there because C is pi halves, C over D. C is pi halves. So, and minus 3. All right. And here's all the pretty pictures. C over B is equal to 1. You can write it as B times x minus C over B. That's where I was confusing myself a bit. You can do it as pi halves times x minus your phase shift, rather than doing pi halves over x minus C. Okay, lots of other possible models. Let's do another example. We want to, I'm going to pause again and get it on the right slide. Okay. Example 3, we want to determine a cosine function for this one. So, since we want a cosine function, we know cosine starts at one of its extreme values. If it starts at the max, then it has a positive a. If it starts at a min, it has a negative a. So you have choices. I see a min there at the origin, and if I start it at the origin, then I won't have any phase shift. So I'm going to choose that one. So I've chosen my starting point. The starting point for my one cycle is the point 0, 0. That means I'm not going to have a phase shift. And I like that. It makes it simpler. So let's find A. We look at the y coordinate of a max would be 1, and the y coordinate of a min would be 0. So 1 plus 0 divided by 2 is equal to 1/2, and that should be minus. D is the plus. So 1 minus 0 is equal to 1/2. So my vertical stretch is actually a compression of 1/2. My midpoint is equal to 1 plus 0 divided by 2, which is 1/2. So my midpoint is 1/2, and my vertical compression is 1/2. Now we want to find my period, so let's look at the difference between two mins. And the difference for between two men's is 0 to pi over 2. We look at the x coordinates. So 2 pi, not pi over 2. 2 pi minus 0 is 2 pi. So b is equal to 2 pi divided by 2 pi, because it's 2 pi divided by p, which is 1. Easy peasy. So, we already figured out that c over d is equal to my phase shift. C over b is equal to my phase shift, and my phase shift is equal to 0. So that means c is equal to 0. So now all I have to do is write down my function. Y, or f of x, is equal to a, and it's going to be negative because we start at the min instead of the max. So minus 1/2 times cosine of b is 1, so it's just 1 times c is 0, and then plus 1/2. Let's see how we did. Negative 1/2 cosine of x plus 1/2. We did great. Okay, try this one on your own. We're going to write a sine function, and remember, you may have a different one than the one that I have when we come back and compare answers, but it still might be right. I promise you on test day, it will be easier to pick the points out. They'll be labeled for you or very obvious with a nice grid. These were kind of hard to read on this one, but I decided to start there at the point 0, because it was easy to read. My max was at 3, my min was at 1, y values. So a was 3 minus 1 over 2, so 2 over 2. My d, my vertical shift, was max plus min over 2, so 4 plus 1, 3 plus 1 is 4 over 2 is 2. So we have no vertical stretch, and we are shifted up 2 units. It increases after our starting point, so A is a positive thing. My period, this one, it was kind of hard to see the difference between the x-coordinates of 2 maxes or 2 mins, but you could kind of tell that the period was equal to 2 pi. And because by the time you get to 2 pi, you start here and you're back to your midline. So there's the midline there at pi, and again at 2 pi. So the period was 2 pi, it wasn't shifted, so it was just the sine of x plus 2. Let's look at example 4. This is more the type of thing you would see on test day where you can actually tell where the points are. So let's look at example 4. We want to write a sine and a cosine function for this graph. So let's start with the sine function. Some of the things are going to be the same. The a and the d will be the same. So let's find those first. We'll look at our max. The y-coordinate of our max is 3. The y-coordinate of our min is -1. So A is 3 minus -1 over 2, which is 4 over 2, which is 2. D is 3 plus -1 over 2, just the average, 3 minus 1 is 2 over 2, which is 1. So our midline is at 1, and you can tell by eyeballing it that our midline is at 1, and our vertical stretch is 2. So those are going to be the same for both sine and cosine. Now let's talk about sine. Our starting point, if we want to have our starting point here at the origin, and let's just do that. If the starting point is here on the y-axis, it's not the origin because it's the point 0, 1. So, for sine, you need a starting point on the midline. We could choose this point at 0, 1, and we'll have a negative a. We could choose the point pi over 3 and 1 and have a positive a. Up to you. So, I'm going to choose my starting point, 0, 1. That means that my a is less than 0 because I'm decreasing. Now let's figure out my period. Period is going to be the same for both sine and cosine. So we'll look at the x-coordinates of these two maxes here. I have a max at pi over 2 and negative pi over 6. So pi over 2 minus negative pi over 6. Well, that's 3 pi over 6 plus pi over 6 is 4 pi over 6, which means my period is 2 pi thirds. So B is equal to 2 pi divided by 2 pi over 3, which is 2 pi times 3 over 2 pi, which is 3. My phase shift is C over B, and we look at the graph to find the phase shift, and since I started there at x equals 0, my phase shift is 0. So for sine, my phase shift is equal to 0. So C is equal to 0. So for sine, I have y is equal to negative a is 2, negative 2, sine of b was 3, x, and then my d was 1, plus 1. Now for cosine, b stays the same, but I have to find a starting point at a max or min. I have two maxes sitting right here. I could choose either one of them, or I could choose this min. I'm going to choose minus pi over 6 and 3. Then my phase shift is minus pi over 6. And since I'm starting at a max and decreasing, that means my A gets to be positive. So y is equal to A, which was 2 times cosine. Oh, I need to figure out what my C over B is here, or I could just put in my B, which is 3 times x minus negative pi over 6 plus 1, which is 2 cosine. And see, I didn't figure out what C was. I just figured out my phase shift. So I look up here, phase shift negative pi over 6 is equal to C over B. So negative pi over 6 is equal to C over 3. So I could write it as 3x minus C, and C is negative 3 pi halves. Now, I'm going to plug these into Desmos and show that we get the exact same thing. Okay, you can't see the first one because they're exactly the same graph. There's negative 2 sine of 3x plus 1. There's 2 cosine of 3x plus pi over 2 plus 1. Now let's see how we did it in the PowerPoint. Oh, it was a practice. No, it was a, here we go. Now this one, we did it the exact same way. So we could have done it by shifting my, oh no we didn't. This one we did the sign and we have a positive 2. So you can see instead of keeping my starting point here, when I did the PowerPoint, I put my starting point over at pi over 3 and 1. So I came up with a different function. I had a positive 2. So either way you want to do it. Alrighty. Yes, you can actually read the digits on this grid. So you should be able to do this one. Give it a try. We'll come back and compare answers. How'd that one go? Okay, it was a little hard to read the numbers, but it was mostly easy. We did have a 1/2, but you could pretty much tell that the midline happened there at a half. So the max was a 1, the min was -5, so A was 1 minus -5, so 6 over 2, which is 3. My vertical shift, D, was 1 plus -5, so -4 over 2, which is -2. My period, I looked at the distance between these two maxes. You could have looked at the distance between those two mins or between these two maxes. But either way, you would get 6, 7 minus 1, or 4 minus -2, or 1 minus -5. No matter how you do it, your period is your period is 6. So your B is 2 pi over 6, which is pi over 3. So for sine, you look for a midline. So the midline is right here at -1/2. You also could have come over here and had your starting point at, actually, let's see, my midline, my midline is at 1/2. My midline is at -2. So it's at -2 right there at -1/2. It's also at -2 right over here at 2.5. So you could have shifted it to the right 2.5 units. I shifted it to the left 1/2 unit. There, now I finally said it correctly. So I went ahead and did the C over B and figured out what C is equal to. But really, when you're doing it this way, it's a whole lot easier to just use the fact that it's B times X minus the phase shift. So x minus negative 1/2. But if you do the algebra, distribute the pi over 3, you end up with that c there that I solved for on the other side. For cosine, I decided to start at this first max at 1, 1, so we shifted it to the right 1, so it's just pi over 3 times x minus 1. Let's do another one. Actually, we have 2 more to do. So I'll start with the one on the left, and then we'll compare, and then we'll do the one on the right, and we'll compare.